Alright, welcome back to my YouTube channel. Today we'll be solving the May June 2018 past paper variant 4.1. So the first question wants us to define the term compound. A compound is a substance made from two or more elements that are chemically bonded combined. Not physically, so not like a salad. Pure substances are elements and compounds are just made by those elements, and they're chemically bonded, so they can be bonded ionically or covalently and so on. So now for part B, mixtures that can be separated by physical processes. So we have the sodium chloride, which is a common salt, and we have the sand, and we're trying to separate them. So the first thing you're going to do is to dissolve this. So you're going to dissolve this mixture in water, and then once it's dissolved, you're going to filter it. You're going to place it in this apparatus, which I'll show you here. You're going to place it, and it's going to pass through the filter paper. The water and the common salt will pass through because they're small enough, but the sand will be stuck up there because it's too large to pass through the little holes in the filter paper. Now you have to filtrate. Now what you can do in order to get the salt or the sodium chloride from the water is to simply evaporate it. Another word for it is crystallization. You can leave it out and in the open and it can evaporate on its own, or you can speed it up by placing a Bunsen burner underneath and just heating it up like the apparatus shown there. Then the water evaporates and you're just left with the salt on its own. Now part C, they're asking us to label X, and X in this case is the condenser, and the water moves in from the bottom and it gets out from the top. So always remember it goes from bottom up. So now part I, so we're asked to find out what's missing in this fractionating column, and that is the stopper, so make sure to draw that. And then the experiment will just not work without it because the alcohol that ends up turning into gas will escape, and well, we kind of need it, so that is the reason. Now part I, the Bunsen burner is not used here because alcohol is flammable and you do not want some sort of accident. Now for part IV, a hot water bath cannot be used to separate alcohol C and D. That is because the maximum temperature the water bath can reach is 100 degrees Celsius, and C and D both have a boiling point above of that, and so that means they cannot be separated. And yes, the boiling point of water is 100 degrees Celsius. Now for question 2, we have ferrovium, which has atomic number 114, and they're telling us that plutonium is 94, and ferrovium is made of both plutonium and another element that's Z, and we have to find what Z is. So plutonium plus Z gives you ferrovium. So 94 plus Z gives you 114. So then Z would be 114 minus 94, which is 20. So now we have to find the element with atomic number 20, and that's simple. Just check your periodic table, and that's the last page in your question sheet, and that is calcium. So the identity of element Z is simply calcium. Now, in which period of the periodic table is ferrovium? It's in period 7, so if you check out your periodic table, you start with 1 where helium is. Period is the row, so 2, 3, 4, 5, 6, and 7. You'll find it right there on the 7th period. Now, predict the number of outer shell electrons in an atom of ferrovium. There are going to be 4 outer shell electrons because it's in the 4th group. For example, carbon has 6 electrons, so its electron configuration is 2, 4. So in the first shell it has 2 electrons, and then the second shell it will have 4. Same with all the other elements in the 4th group. They're all going to have the outer electrons, a number of 4 electrons in their outer shell, no matter how many shells there are. So part D now. But here, of course, I'm just showing you the groups. So part D, state the term used to describe isotopes with unstable nuclei. It's simple, that's just radioisotopes. Now we're going to complete the table to show the number of protons, neutrons, and electrons in atoms of the isotopes shown. So for ferrovium, the number of protons is 114 for both. Number of electrons is going to be exactly the same. Now with isotopes, it's the neutrons that are different. So 286 minus 114 gives you 172 neutrons. The 286, that's the nucleon number. That is or in other words the mass number, which is the sum of both the proton and the neutron number. So we're just going to subtract the proton from it and it'll give us the neutron. So we're going to do that for both and it'll give us the answers. Alright, so then part E suggests two physical properties of fluorurium. They told us that it acts like a typical metal, so it can have a high melting point or boiling point, and that it can conduct electricity. Now, we're going to suggest the chemical property of the fluorurium oxide is going to be basic, because it is a metal, right? And non-metals have acidic oxides, for example, sulfur trioxide. So I'll just show you like a couple examples. You have sulfur dioxide, carbon dioxide, phosphorus, V oxide. All of them, they're all acidic oxides because they're non-metals. Now for question 3, name one other raw material that's added to the Bunsen burner that isn't mentioned. So we have the coke, which is something that contains a lot of carbon. We have the iron ore, which another word for is hematite. And we have the limestone. What else is missing is the hot air that passes through. So you need to place that it's one of the raw materials that are needed. Now they want us to explain the steps that occur in the Bunsen burner. So we can use words or equations to solve this. So first thing, the coke is burned to form carbon dioxide. So C, which is carbon, plus oxygen gives you carbon dioxide. Then the carbon dioxide is reduced by more coke to form carbon monoxide. Of course, reduction is the gain of electrons or the loss of oxygen. Now they told us to place the chemical equation of the reduction of hematite. Like I said, hematite was the iron ore or the iron oxide. So Fe2O3 will give you iron and carbon dioxide. Make sure the equation is balanced. Now, the limestone decomposes to form lime and carbon dioxide. So the limestone is calcium carbonate, will decompose to form calcium oxide and carbon dioxide. Now this calcium oxide will react with the silicon oxide. This silicon oxide will form calcium silicate, which is the slag, which is also a chemical equation that they asked us to show. This silicon oxide is found as an impurity as well when we have the iron ore, because it's found with sand and stuff. Now for part C, they asked us to find the main impurity. The main impurity in this is carbon. And we can get rid of it by blowing into or passing oxygen through it, through the molten iron that is, and then the carbon reacts with the oxygen and it forms carbon dioxide gas, which escapes. So then it's purified. Now the equation is about masses, volumes, and moles. So which is the term that defines the average mass of naturally occurring atoms of an element on a scale where the 12th carbon atom has a mass of exactly 12 units. That's the relative atomic mass. Now, atoms of an element. So the only reason they put an S there is because some elements are stable and are combined to more than one atom. For example, hydrogen and nitrogen, oxygen, fluorine, phosphorus, sulfur, and so on. Now, explain why the term relative molecular mass can be used for butane but cannot be used for potassium fluoride. That is because butane is covalently bonded and potassium iodide is ionic. So when nonmetals bond together, that is a covalent bond. They're sharing electrons, but when metals bond together, that is an ionic bond because they'll be transferring an electron from one metal to the other. Now, a 0.095 gram sample of gaseous element Y occupies 60 centimeters cubed at room temperature and pressure. Determine the number of moles of element Y in that place. So 1 mole of any gas at room temperature and pressure takes up space of 24 decimeters cubed. So we're going to change that 60 centimeter cubed into decimeters first, and so you're going to divide by 1,000. So 1 mole gives you 24, X will give you 0.06 decimeters cubed. You're going to cross multiply and X will give you your answer. And that's the number of moles of element Y, which is 2.5 times 10 to the power of negative 3 moles. Now we need to calculate the relative molecular mass of element Y and hence suggest the identity of it. So 1 mole of Y is X, we don't know how many grams, but 2.5 times 10 to the power of negative 3 moles is the 0.095 grams, which they told us, right? We're going to cross multiply and find what X is. X will give you 38 grams. So now what we're going to do is look at the periodic table and figure out what the 38 is. Why is fluorine? Because 38 divided by 2 is 19. So it specifies in the question that Y is a gaseous element, right? And fluorine is a gaseous element with a relative atomic mass of 19. But it's written as F2, that's where it's stable, it's a diatomic element. And so 19 times 2 is 38. So now for D, 1.68 gram sample of phosphorus was burned and formed 3.87 grams of an oxide of phosphorus. So we need to find the empirical formula. So the empirical formula is quite simple. It's basically the whole number or the simplest form of a molecule or a compound. So for example, if it was P2O2, the simplest form would be PO because the 2's cancel out. And for example, CO2 or carbon dioxide, that's the simplest form because you can't divide the 1 by 2 or then you'll have a fraction and not a whole number. So we're going to place the 1.68 to the 2.19 grams next to each other. Then we're going to divide by their atomic mass. So that will give you the answer of 0.054 and 0.13. Then we're going to divide by the smallest number on both. So that will give you 1 and 2.5. We can't have a decimal, so we can get rid of that 2.5 by multiplying by 2. So then the empirical formula would be P2O5. Now for part E, another oxide of phosphor has the empirical formula P2O3. We need to find the mass of 1 mole of this oxide of phosphorus. So P2O3 times 2 will give you P4O6. So they told us that 1 molecule of this oxide of phosphorus contains 4 atoms of phosphorus. So we're just going to multiply by 2. So phosphorus is 31, the atomic mass, and oxygen is 16. So 31 times 4 plus 16 times 6 will give you 220 grams. That's your answer. Okay, so for question 5, we need to define the term catalyst. And catalyst is a substance which increases the rate of a reaction without being used up in the reaction itself. It's unchanged. Now, give one other chemical property shown by transition metal which is not shown by group 1 elements. The fact that they have variable oxidation states, examples of iron 3+ or iron 2+. Now we're going to give 2 other physical properties shown by transition metals or elements which is not shown by group 1 elements. The fact that they're harder, they're stronger, they're denser, they have a higher melting point or a boiling point. These are all options that you can place in there. And you know, group 1 elements are quite soft and they're not very strong. Now for part C, we're going to place the missing products. So that would be zinc, sulfate, and hydrogen. Because zinc plus sulfuric acid will give you zinc sulfate plus hydrogen. So the zinc has an oxidation state of 2+, and the sulfate would have an oxidation state of 2-. So you're going to put 2 and 2 at the bottom, right? But it can cancel out, right? And so the ratio is 1:1. So zinc sulfate is written like that, plus the hydrogen. Now, they told us to place the activation energy. The activation energy is going to be between the reactants and the highest point, and that's the energy that's needed in order to start the reaction. And it's going to be facing upwards. So make sure the arrow faces upward and not downwards because you need more energy, not less energy. Now this reaction is exothermic because the products are at the lower energy level than the reactants. Exothermic means the release of energy and endothermic means gaining energy. So if it was endothermic, the products would have more energy than the reactants, so they'll be placed above the reactants. Anyways, for part D, this is what the activation energy would look like if we had a catalyst. Like we said, it increases the rate of reaction without being used up. So that means a way for it to do that is to lower the activation energy. So you don't need a lot of energy in order for the reaction to start. That's why the curve is lower. Now for part EI, they told us to write an ionic half equation for the reaction at the negative electrode. So we have copper sulfate or copper 2 sulfate, so Cu2 plus 2 electrons will give you the copper solid. Of course, the copper ion is going to go to the negative electrode because that's what it's attracted to. Opposites attract, right? Now the copper sulfate, same again, Cu2+ and the sulfate has an oxidation state of 2-. Both the 2's cancel out and you'll have copper sulfate written like that. Now they've told us to find or to describe what the student might observe at the negative electrode, they're going to observe a solid or some sort of deposit that forms, and that is the copper solid. And the thing is, the color is salmon red, or you can say pink, but it slowly turns brown when it reacts with oxygen. That is the copper 1 oxide forming. So in the mark scheme, they placed it in brackets, so you do not have to specify the color, but all you have to say is that a solid forms or some sort of deposit forms, and that is, you don't have to specify that it's the copper because that's just an observation, but for you to know that is the copper solid. Now, give two other observations. One would be the bubbles forming at the anode, which is the positive electrode. When you have an electrolyte of a sulfate in it, basically like the copper 2 sulfate here, the sulfate never escapes. Oxygen is what escapes instead, so that is the bubbles that you see. And also the solution becomes paler. That's because the copper ion, which is the one that gives that blue color, right? But it decreases because it's forming the copper solid. So that means if there's less of that copper ion, that means the blue color is going to start becoming, paler. So now for the next question, if sulfate was replaced with copper chloride, we'd find chloride gas, which is a green gas, instead of the oxygen. Like I said, the sulfates and nitrates and carbonates do not escape, but oxygen does instead of them. But in this case, it's the chloride, and so the chlorine gas would escape. Okay, so for question 6 and the last question, why are compounds P, Q, R, and S known as hydrocarbons? That's because they contain only carbon and hydrogen, and make sure that you place the word only because they only contain carbon and hydrogen. Now, for part B, what is meant by the term saturated? Now, compound P is saturated. That is because it only has carbon-carbon single bonds, not double or triple, and they are usually unreactive. Now, compound P undergoes a substitution reaction with chlorine. What is meant by the term substitution reaction? It means that an atom or a group of atoms are replaced by another atom or a group of atoms. That is literally it. Now, state a condition required for this reaction to occur. You're going to need ultraviolet light in order for this to happen. That's what I meant by the fact that saturated compounds aren't really reactive. Now, write a chemical equation for this reaction. Okay, so compound P is actually ethane, yes, and that is C2H6. Plus the chlorine will give you C2H5Cl plus HCl. That is because it's a substitution. Like we said, one of the atoms is substituted, right? So one of the hydrogen is taken away and is substituted by a chlorine instead. So this is known as free radical substitution, but you don't need to know that until next year. So now for part D. So compound R undergoes an addition reaction with bromine. So why is it an addition reaction? Because only one product or compound is formed. The double bonds would break, and instead you'll have single bonds formed with the bromine atoms. So now we're going to show you how it's drawn, or the mechanism basically. So CH2 double bond CH and CH3. Of course, carbon can only form 4 bonds, so the double bond would open up, right? And then the bromine atoms will go into each one, right? So you can have the Br at the top or the bottom, it does not matter, because single bonds can actually rotate. And so whether you put it at the top or bottom makes no difference. It's still correct. So now for the next question, which is part E, I guess. Well, no, it is part E. What am I saying? Okay, so for part E, draw the structure of the unbranched isomer of compound S. So isomers, basically, they have the same molecular formula, but they have a different structural formula. So S is CH2 double bond CH and so on, but instead of putting that double bond on that side, we can place it in the center, and that would be a different isomer. So unbranched means that there's a double or triple bond, but when it's branched, it means that it only has single bonds. So now we draw it out, we have it like that, and then we have to name it, right? So there's 4 carbons, so that is going to be but, and then the double bond is in the second carbon, so that's but 2, and then ene, because alkenes end with E and E, alkanes end with A and E, and alcohols end with OL, and so on. We can't place the double bond on the end because then it's basically the same compound but flipped. So you have to watch out for that. Make sure that you're not just repeating the same compound again. So now for compound Q, it undergoes polymerization. So compound Q is ethene, and it's going to form a polymer, and that polymer is going to be polyethane, because once you open up the double bonds, you're going to have ethane, which is an alkane which has single bonds, and you're just going to add more and more and more. So this is the monomer. This is just the one unit that's going to be constantly repeated, so it's polyethane. So now complete the chemical equation to show the polymerization of compound Q. So we're just going to open it up like we did earlier, and we're going to place two lines on the side, meaning more CH2 can bond together to it, and being the number of CH2, which is the number of monomers. So it just keeps adding and adding and adding. It's just going to look like that, and that's it. So now for the second last part, amino acid undergo polymerization. So we're supposed to draw here the amide linkage that's missing. So this is a typical amino acid and another amino acid. So the H that is connected to the nitrogen and the OH that's connected to the carbon will bond together to form water, and that would be released. Then the nitrogen and the carbon would bind together, and that would be the amide linkage, and that's what it's going to look like. So then we just have to replace that in each of these amino acids. So we have the N and the H for the first one, and then the white block being the stuff in the center. Then we have on the outside is the carbon with the double bond O connected to the nitrogen and the hydrogen. That's the amide linkage. And then on the other side again, we're going to have the carbon and the double bond O with the nitrogen and the hydrogen at the bottom. So in each one, there's the carbon part and the nitrogen part for each and every single amino acid. So that's 3 of them that's being bonded together, and that's it. So now for part H, we're going to write the word equation for a reaction which could be used to make this ester. So in order to find out what this ester is made of, we place a line where the O is there, where the O is. So you count how many carbons there are. There's 4 carbons, and then with the one with the double bond O, that's going to be the carboxylic acid part. So again, 4 carbons, so it's going to have the prefix of but, so butanoic acid, plus the alcohol, which is going to be ethanol, because there's 2 carbons, the prefix is eth, so ethanol. So when we draw it, we draw the carboxylic acid first and then the alcohol. But when we're naming it, we name the alcohol first and then the carboxylic acid. So it's going to be ethyl butanoate plus the water, which is released because, again, the hydrogen and the OH bond together to form the water, which is the same as the one with the amide linkage of the amino acids. Anyways, you guys, that was a pretty long paper, but we are done. Congratulations. Yeah, if you want me to do any other past paper, or if you have any questions, just let me know down below in the comment section. And yeah, I'll see you guys next time. Bye.